Mpirical provide compelling, interactive learning across a range of delivery options. Live on site, live online, or online anytime, we have a training course that is ideal for you. For a no-obligations chat about your training requirements, contact us at mpirical.com.
In this session, we're going to discuss SS7 terminology. So we're going to start by looking at the term signaling link, what that does mean, signaling link set. We'll also look at the term signaling points and signaling transfer points. Other terminology includes signaling routes and signaling route sets, and then finally we'll focus on signaling point codes. So if we take a basic network where we're going between two devices and we've got a switch involved, and the idea is we want to put some traffic circuits between these switches, we'll identify that each of these switches will have a signaling terminal, and ultimately inside there you'll see this term signaling point. Now the term signaling point is where we start utilising the services of SS7, the MTP, the message transfer part of SS7. So it's where the signalling goes in and when it pops back out. So a signaling point is effectively the starting and end point within the world of MTP, message transfer part. So between these two signaling points, in this example, I have a signaling link. Now a signaling link in this example might be a 64K circuit, so a time slot being reserved for signaling. Now it is possible that you could have multiple time slots, and you might hear the term a bit later, signaling link set, or you might find that the signaling link is a high-speed signaling link. So it could be, for example, a E1 T1 bearer. In terms of the terminology then, so here's my same example. I've got a signaling terminal. We could have a bearer in place, so this is a E1 or a T1 bearer, and now what I'm saying is I'm going to utilise a signaling link, which could be a 64K, but for certain scenarios it might be a 56K time slot. And if we use one of those time slots, that is now a signaling link. Now it is possible that we could have multiple time slots, so let's just put another one in place. So now I've got two time slots allocated to signaling between these two signaling points. What's the terminology? Well, the terminology is now a SLS, or a signaling link set. So typically signaling links are in groups of, or multiples of two. So typically you'd have two signaling links, 4 links, 6 links, 8 links, for example. Why? Well, we'll see later, but it's to do with load balancing. So we have a signaling link set. We also have signaling link selection. Now a signaling link selection is identifying which signaling link you would like to use, and that's part of the allocation process. So for example, the higher layers, now the higher layers are above MTP, for example ISUP or SCCP, is going to identify the signaling link it wants to use. For example, the application here, the higher layer, SCCP, has allocated SLS value signaling link selection number 6. So what does that do? Well, in this example, I've got multiple signaling links numbered 0 to 3. So I've got 4 signaling links. That's my signaling link set. Now it's very confusing because we've got SLS signaling link set, the 4 links, but we also now have the SLS signaling link selection, value number 6, used as well. So the SLS acronym is used twice. But what would happen is as that information arrives at the signaling point uses the signaling link selection value, number 6, to define which signaling link I should go down. So in this example, we're going to map it and load balance it across the 4 signaling links, and would have a table as shown. Now notice the signaling link selection value goes from 0 through to 15, and what I've done is I've mapped them across the different signal links. So in my example, because I'm using signaling link selection value 6, I'm going to use signaling link number 2. So that's where I'd expect the signaling to be sent for this particular user. Now you might say, well, signaling link selection value 6 always goes down signaling link 2, and that would be the case unless there was a failure of that particular signal link and we'd have to remap the table. So how do we actually load balance? Well, the load balancing is actually done by the application, the higher layers. So by the higher layers, changing the value of SLS, signal link selection, it sends down to the MTP. That's going to effectively load balance. So if the application here was to change it to, for example, value 9, that would map to a different signaling link. So when we talk about signaling links, you can have what are called low speed signaling links. Now low speed signaling links are typically 64 kilobits per second, but you might find 56 kilobits per second. But we also have this term high speed signaling links using our T1 and E1 bearer. So obviously their rates are a lot higher. And that's what you might use towards things like a database. So we have now signaling points, signaling links, signaling link selection, and a signaling link set. There's a terminology so far. The next thing I want to talk about is a STP, a signaling transfer point. Now, rather than going between these two signaling terminals, what I might decide to do is change the configuration slightly, that I've got another route through the connection. So what I can do is I can go through a STP, a signaling transfer point. And I might be doing load balancing of signaling, or you might find that these are different priority routes. For example, if the signaling between the 2 points fails, we can go round through the STP, the signaling transfer point. So why is it a signaling transfer point? The terminology is MTP is relaying it, and it's not actually going up to the higher layer application. So we have an STP. The other term is a signaling route. So between these two signaling points, we want to go and send some messages. And you can see that I'm using a mesh structure with multiple STPs or signaling transfer points in place. And what I'm going to provision in my SS7 network is a signaling route using, for example, these signaling links. And that now is my signaling route defined. So we have a signaling route. Now the idea is, part of the administration, we need to set these routes up. So this is the route. What would happen if there was something wrong with that signaling route? Well, we might need to go to a backup. Now, what we need to do is have possibly other routes. So we could put, for example, another signaling route in place. This terminology now is called a signaling route set, all the available routes between the two signaling points. It's also worth pointing out that you might do load balancing across these, or you could find that they have different priorities. So one of them is priority 1 and one of them is priority 2. So we typically use the priority 1 signaling route unless there's a problem, and we can fall back to the priority 2 signaling route. Finally, I want to talk about the term signaling point codes. Now, a signaling point code is possibly an international signaling point code, so it's been identified by the ITU, allocated by them, the International Telecommunications Union. Alternatively, we have what's called national signaling point codes. Now, in both cases, we're going to have a field for the signaling point code. So let's have a look at the International Signaling Point Code. It's actually made up of 14 bits in what's called a 383 format. The first 3 bits are identifying the zone or the region. The next 8 bits are the area network identification. Together, this provides something called the signaling area network code. Examples of a signaling area network code are illustrated here, and as you can see, a service provider in Great Britain could be allocated 2, because that's based on the zone, the region, and 068 being allocated as the network identification. And with that effective identifier, you then get 8 signaling points. So you can see we have 8 signaling points per signaling area network code, and that obviously provides some flexibility. Now, how do we use signaling point codes? Well, if I have a scenario, I've got network A and network B. Now, it's worth pointing out, within a network, you can use any signaling point codes typically, because it's a national network. So you can use, for example, signaling point codes 23, 4 and 19 used in network A. Network B could utilize the same signaling point codes because they never leave the MTP part of the network, and therefore these two service providers' networks are not communicating. However, if I wanted to send, for example, a signaling message from one network to another, we have to have some methodology of bridging that gap. So the idea is we would start, for example, at signaling point 23 in network A, and we need to get across into network B. How do we do that? Well, what we're going to need to do is think about what connects these two networks together. And typically we're going to need some higher layer application. And this might be ISAP or SCCP, for example. And that can do global title routing. So signaling messages can arrive on these nodes and be routed again across another MTP network. And in this case, I'm showing X and Y. So X and Y could be as part of the international signaling circuits, for example. So we can now go from signaling point 23 in network A up to this another signaling point, but in this case it's hitting this node saying, right, that's as far as I can go. I'll go up to the higher layers and then I'll go across, in this case, the international circuits, arriving at network B, and then I can be forward onto the right location. So MTP is very much national roaming, international roaming, but it doesn't bridge the gap. We need some higher layer signaling from ISUP or SCCP as an example. So in summary, we've focused on SS7 terminology. So just to recap the terms, we had a signaling point. A signaling point is the initiation or the reception of signaling at the MTP level. It may utilise the services of a STP, a signaling transfer point, so that routes at the MTP level. We had a signaling link, and this could be a low or a high speed signaling link. But we also had the term signaling link set. So for example, if we had 2 time slots allocated for signaling between 2 switches, that became the signaling link set. There was also a signaling link selection, which is used by the higher layers to identify which signaling link we would like to go down. And that is used in the, if you like, load balancing process. We've identified the term signaling route, how we route signaling from one signaling point to another signaling point across the SS7 network. We also had a signaling route set, all the potential routes that we had between 2 signaling points, and that might be for load balancing or priority based. And then finally, we've had a look at the signaling point codes, identifying that there are international signaling point codes allocated by the ITU in a 383 format, but we can also use national signaling point codes, which effectively a service provider can use, and you might find the same point codes are used in different service providers' network, but because it's at the MTP level, they can't communicate. And we have to go up to the higher levels to actually facilitate interconnections between service providers.
Need to know more? Why not visit our store, where you can choose from over 200 hours of video-based training. Alternatively, you can contact us to discuss any specific training requirements you may have.